I'm standing here at the University of Manitoba in the Max Bell Center Fieldhouse at the Manitoba Schools Science Symposium. Now, this symposium provides the chance for students all across Manitoba to showcase their scientific research and their studies that they conducted on display boards that you can see behind me. And so we had the chance to interview a co-chair of the organizing committee, as well as some students that are actually partaking in the symposium and showcasing their research to judges. I'm standing here next to Rowan Setti, who is a co-chair of the organizing committee of the Manitoba Schools Science Symposium. And so Rowan, this symposium, I understand it's an annual event. It's been going on since 1971. What's the whole point of hosting this event year after year after year?
Yeah, so the Manitoba School Science Symposium, or MSSS as we like to call it, is a platform for participants to showcase their ingenuity, their intellect, their creativity, and their curiosity. Our goal is to provide a platform that can foster the next generation of scientists, researchers, innovators, physicians, engineers, and so forth. And so the opportunity for these participants to be able to show what they know, to be able to learn the scientific method, and to be able to feel confident that they can put together a project that is worthy of themselves, and that is something that would help boost their confidence for future years, is our ultimate goal.
And I understand this is a 3-day event, so today is Saturday,
Yep.
right? It started on Friday,
Yep.
It's going to end on Sunday. Can you comment sort of what happens on each day? Why is it not just, held on one day as opposed to 3?
Well, I feel like it's also more fun if we give kids a 3-day event and they also get the day off on Friday. So Friday is when we do our project setup, which in itself is quite a large-scale operation, as you can imagine. We've got over 300 participants from grades 4 to 12, and so we get them to set up their projects. They undergo a safety and ethics check, of which I'm actually also the chair, and so what we do is we make sure that there's no loose cords, electrical wiring, get all those logistics out of the way, and then the afternoon is spent doing Friday activities. So they're divided into groups. The grades 4 to 6s have their own activities, the 7 to 12s have their own activities, and what we're doing is we're giving them an opportunity to get hands-on again in different ways. Yeah.
And so can you also comment about the judging process, right? I understand that there's awards involved, right?
Yeah.
What are some of the criteria that the judges will be looking for in some of these display boards, as well as what are the awards that some students, could possibly win?
Absolutely. So the more fulsome rubric is on our website, but I can tell you that the judging process involves looking at the creativity, the originality of the project, the presentation style itself. We also encourage students to be themselves, so we're not looking at seeing if they have a script memorized, but more so how they can fluidly engage with the judges to talk about what they've done. What we're trying to do is get them to feel more confident about themselves. This is also a skill that would be part of their lifelong trajectory, public speaking. And so this is more than just about doing science. This is about trying to develop a person's skill set. And so our goal here is not to grill them to a point where it feels like it's a competition where the stakes are at its highest. We do encourage friendly competition, but our goal ultimately is to provide that platform where kids can feel like this is a chance to be who they are.
Mm-hmm. Yeah. And so some of these awards, I think there's plaques, there's medals, right? Comment more about what students could possibly win, if the judges sort of really like their display there.
The stakes are high, so we've got bronze, silver, and gold medals, and separate from our medal awards are our special awards and our grand awards. So we've got plaques and certificates for our best projects in each category. We've got biological and physical sciences are 2 main categories, and there's 4 subsets within each. So we give the best project in each of those categories, as well as best elementary, junior, intermediate, and senior project. And 6 projects are also eligible to qualify for the Canada-wide Science Fair. So those projects are selected to represent our fair and the province at large at the Canada-wide Science Fair, which this year is happening in Fredericton.
Mm-hmm. And so can you also comment, all of these display boards behind us, right? All of these experiments that these students conducted, when did they really start actually conducting these experiments? Was it 6 months ago, a year ago? Is there a timeline? Could, any students start, years in advance if they want, or just a few months? Sort of comment, when could students get involved in this process?
So it varies. So we've got some students who will start about a month or 2 before the fair itself. There's some, especially our senior projects, who are working in labs, some of which are affiliated with the U of M, and they'll be spending months at a time, if not years, working on that project. And there'll be people who come back year after year. So we've got some projects that were here last year where they looked at something a little bit different. This year they're building upon their previous research work. And so there's a lot of variance in terms of how long participants have spent on their projects. But we do encourage that if you're thinking about getting a science fair project started, that you do so as early as possible, so that if there's any bumps on the road, you have time to redo it if you need to.
And a bit more about the outreach. Are all these students that are presenting their research, their findings, are they all, did they work directly with the school on this project? Are some of them projects that they could have sort of, took the responsibility on entirely themselves, separately from their school?
Yeah, so this is, again, our fair is the only fair in Manitoba that has province-wide jurisdiction. There are other science fairs that are specific to school divisions. So we've got participants from private schools, public schools, schools from the north, including First Nations. And so students have the opportunity. Sometimes there will be science teachers who will work with the students and help them bring their project to life. And there will be others who will come on their own merits. They will have done their own research. Sometimes the school supports, sometimes the school doesn't. And so there's a lot of variance in terms of that as well. We do have a large contingent of students from Desmesh School. It's one of the faith-based schools here in Winnipeg. And so they've sent about 95 students this year, which would make up about 1/3 of our fairs. So, yeah.
And so as co-chair of the organizing committee that's responsible for, sort of putting the whole thing on, what would you state is the most amusing aspect of the whole thing to you?
I think it's just getting a chance to see just how many different ideas there are and how many different ways you can present those ideas. So we've got projects on AI, we've got projects on hydroponics, we've got projects that look at cancer, and yet there's so many variations within those sets as well. And so that's a really exciting part about being co-chair, is getting a chance to see kids be themselves. And again, it goes back to that message that I was pointing to earlier. We're trying to provide a platform where they can feel like themselves, present their thought, and be curious about the world around them. Our goal is to foster the next generation of scientists, engineers, innovators, physicians, and so forth. And so I look forward to seeing where they go, later on in their life. But it's a really rewarding part of being part of this fair.
And so, Rowan, I understand you were just telling me there's something special about these display boards here that are perpendicular to all the other boards in their own separate column. Why are these boards different? Why do they stand out?
So these boards aren't your traditional science fair experiments. These are what we call Invent an Alien projects. So these are a cool feature of our science fair where we've got participants who we encourage to come up with their own alien on their own planet. And it's a nice addition to what's usually a science fair filled with experiments about volcanoes and plants and stuff like that. So it not only gives an opportunity to stimulate the creative part of our participants' minds, but it also helps add some more variety and diversity to our fair at large.
And when was this section, really added on to the typical science display boards?
So it's been a few years now since we've had the Invent an Alien as part of our science fair. I don't know the exact year, but it is now a very valued member of our fair, and we do look forward to keeping it part of our fair for years to come.
I'm standing here next to Ella, a grade 12 student. And Ella, I understand your project is on mapping microplastics in Lake Winnipeg. Can you comment on what was the hypothesis that you tried to test and what were the results of your study?
Yeah, so my hypothesis stems from, I've been doing this research for 3 years, and in the past years I found that microplastics and their movement, it's going to depend on turbulence. And so I use an analogy to think about this. Basically, it's sort of like dust bunnies. Where do they accumulate in your house? Not in areas where you're moving around a lot, but in areas where there's not a lot of movement at all, like under your bed. So in low turbulence areas. So my hypothesis for where microplastics are going to end up is in low turbulence areas. And so what I did is I created this turbulence model. And so it's based on fetch and the overall flow of the lake. And so this shows you sort of the high and low turbulence areas of the lake. And so you can see mostly in the southern basin, it's a lot more lower turbulence. In the northern basin, it's a lot higher turbulence. So that might lead you to, based on my hypothesis, you might think, okay, so there's going to be more microplastics in the southern basin than the northern basin. My research actually showed there was, this is another one based on my model. It's meant to simulate where microplastics are in the lake. There's actually quite a lot of microplastics in high turbulence areas. So, how I sort of confirmed this model, and I also created a wind model, which is just straightforward based on wind vectors provided by Environment Canada. How I confirmed these models is I actually spent a month aboard the Nemeo research vessel, which goes out in Lake Winnipeg and samples both the northern basin and the southern basin, and I used a manta trawl to collect samples. And so what this does is it basically skims the surface of the water and collects all this debris. So I've used wet peroxide oxidation to get the microplastics out. I counted the microplastics and I correlated it with my model. So it shows my wind model is accurate, while it shows there's something going on with my turbulence model. So turbulence doesn't exactly correlate directly with microplastic counts. But as I had shown in this simulation, this did correlate with that. And so then the other finding that I had is I took 2 milliliter samples throughout the lake, and I ran stable isotope tests on this. So this is testing for the hydrogen and oxygen isotopes in the water. And so what the results showed was basically how there are many inflow rivers into the lake, so that's contributing to water in the lake. And so the map sort of shows how, when a river enters the lake, how is the water spreading out. And so it sort of showed that water spread it out in the North Basin, and it sort of converged in the middle in this high turbulence area where my red dots test had predicted there would be lots of microplastics.
I'm standing here next to Jessica, a grade 12 student. And so Jessica, can I ask you to explain a bit about your project? What was the hypothesis? What did you want to test? And what were the results that you found?
For sure. So I'm currently interning with Dr. Sabine Kuss at the lab of bioanalytical and electrochemistry. And so through her, I was able to work on this project, which is basically developing a device that takes the apta-sensor approach for detecting mycotoxins in Canadian grain.